All right, now we're moving on to absolute value equations and inequalities with two variables. We'll talk about equations first, and then inequalities we'll go over at the end. It should be really quick because they're pretty much the same thing. So when we talk about absolute value equations, the one thing I want you to remember here is that they will graph a V shape. Okay, and I'm going to show you why using Desmos. When I have y equals absolute value of x, here's the table that it would plot out. Like if I plot out -3, it would give me +3. -2 would give me +2. -1 would give me +1. 0 would be 0. 1 would be 1. 2 would be 2. So you would see this kind of slow downward drop. But again, this is all still positive because we have an absolute value. And then here it turns around and everything remains positive. It would be almost like saying, what would we have if it was just y equals x? Notice this blue line comes down here, but because we have absolute value, we want all of these things down here to be positive, so they kind of flipped up this way and made a V shape. I'm going to get rid of that now. So we make a perfect V shape anytime we have an absolute value equation. Now, our absolute value equations using two variables will follow the basic form of y equals a times the absolute value of x minus h, and then at the end there'll be a plus k. Okay, now notice minus h here and plus k. Minus h plus k. Whatever is being subtracted on the inside of your absolute value equation, that is going to be the positive form on this point. Okay, h, even though it says minus here, we're using whatever is being subtracted. Here where it says plus k, whatever that value is, that is the actual value we're going to use here. Now this hk makes what's called the vertex. The vertex is kind of the corner or the point of our absolute value V shape. So right here would be what's called the vertex. Now as you kind of branch out from that point, we can still think of your line or your lines as having a slope, just like you would for a y equals mx plus b form. Your m is your slope. In this case, your a is the slope from the vertex. I'm going to show you how that all works, again, using Desmos. In this case, we kind of have a hidden 1 on the outside here. Okay, that 1, or 1 over 1, that is our slope. We're going up 1 over 1, up 1 over 1, up 1 over 1. If I all of a sudden said 2, now notice that this orange one kind of changed here. This one hasn't yet. I'm keeping these separate. This red one over here, these values all need to be multiplied by 2 still, right? Because we had the 2 on the outside, so think about what each one of these would be if times by 2. Okay, what would happen is, if I plug in a 2 here, these all get doubled, and that's why all of a sudden it gets a little bit narrower. It's like saying from here to here, our slope is still up 2 over 1, up 2 over 1. So this piece on the outside, that 2 there is kind of like our slope. So if I did like 1 over 2, 1/2, okay, again it's saying, if we come back to this red one, think of this as just a regular y equals absolute value of x. What has to happen to each of these? Well, each of these has to be cut in half. So instead of 3, it'd be like 1.5. Instead of 2, it'd be 1. So if I cut each of them in half, that's why it kind of flattens out more, becomes a little wider V. So again, it's kind of like thinking from this vertex, we go up 1 over 2. Oh, let me get that right on, up 1 over 2. Okay, that's where we get these points from. It's this as our slope. Okay, I'm going to get rid of that slope. So we just have our regular absolute value equation again. Okay, the next part I want to look at is this plus k. This plus k is a vertical shift in your V shape. So if on the outside here I go plus, oops, not equals, plus 4, what has to happen to all of these things? Well, literally all they're doing is just adding 4. They're shifting upwards. Okay, notice what that does with our vertex. Whereas down here it used to be way down here at 0, 0. When we add the 4, it just kind of shoots up 4 places, gets to this spot. Okay, if I were to do a minus 3, notice it goes downwards by 3. Okay, it comes down to a 0, negative 3. So as of right now, we kind of have a plus 0 in here. So notice 0 is like our h, or actually I should say minus a 0. 0 is our h, negative 3 is our k. If I went back to that plus 4, 0 is our h, 4 is our k. So this spot, this vertex, is determined by whatever's being subtracted here and then added here. Okay, I'm going to go back now and let's talk about that h on the inside. How it does the outside one, the k, does a vertical shift. The h on the inside will do a horizontal shift. So if I do minus 2, notice how the orange one shifted 2 to the right. Okay, it might be kind of weird to think, why did that one shift right if we were minusing 2? Well, remember, I said in here, whatever's being subtracted, that is your vertex, right? So if it's minus 2, you use 2 for the x value of your vertex. It's kind of the opposite. Now, why does it make sense that it should be opposite? Well, again, think about it. Whatever you plug in here, you have to subtract 2 first before you even take the absolute value. So if I plug in negative 3, I have to subtract 2 to get negative 5. Then I take the absolute value. So the trick here is we think of our vertex as the place where the absolute value is 0. Okay, when our absolute value is 0, right here at 2, this is where we have our turnaround point. Everything else is kind of a mirror. 5, 4, 3, 2, 1, then 0, then 1, 2, and 3, 4, 5, and so on. So when the inside of the absolute value piece becomes 0, that is our vertex, or that's our mirror. And what do we need to make that 0? Well, we need x to be a positive 2. So even though this says minus 2, our x needs to be positive. That's why this is a positive 2, 0. So let's look at what happens when I finally put it all together. When I have a minus 2 and a plus 3, again, we can see now my vertex is at this positive 2, positive 3. Even though this was minus, this was plus, they're both positive in here. So if I were to go plus 2 and plus 3, this would actually be a negative 2, 3, right? Because it's actually a negative 2 that's being subtracted here. That's why this one moves leftwards or comes to the negative 2. So always think of this as what is being subtracted from x. Okay, we can also look at, I'm going to go back to putting these together. X minus 2 plus 3, so these are both on the same spot. Now let's think about what would happen if I put my slope with this here. So if I put a 3, okay, notice 3 didn't really change anything except all these other points. The vertex is still where it was at this 2, 3. So the 3 doesn't affect the vertex. The only thing that affects the vertex was this point and this point, right? Plus 3, so our y value is 3. Minus 2, so our x value is 2. So we change the vertex based on these two. We change our slope based on this one. Now, it is possible for you to have a negative slope. If you have a negative on the outside, notice that that shifts everything downwards. So again, what we're doing is, you can see here, all of these values are still 3 apart because of that slope. Just like with a linear equation, these would all be 3 apart because of our slope. We're just saying this vertex is at this point because of these two. That 2 and the 3 changes where the vertex is at. So that's going to be your basic form, or what you need to do at the basic level of our absolute values. Now, if you noticed before, though, I do have a piece underneath. This is where things get a little more complex. Sometimes you will have something in front of your x inside of these absolute values. The trick here is we think of this whole piece. So I'm going to go like this. Our absolute value part, we think of it as something with, let me go like this. If we had 2x plus 4. If we had this in parentheses, we would think, okay, I can factor out a 2 from both of these. If I take the 2 to the outside, now all of a sudden this becomes a 1 or goes away, and this becomes a 2. Right? I'm just factoring it out. We're doing the same thing here. We need to factor out this b to get this back to just a 1. So no matter what the b is, positive or negative, you're going to factor it out. When you factor it out, your new vertex is going to be h over b as your x value, and then just k as your y value. Your new slope is going to be a times the absolute value of b. Because b was inside of the absolute value, if this was like a negative 2 times x in here, you're actually just timesing your slope by 2, not by the negative 2. So your slope would be a times the absolute value of b is your new slope from the vertex. Okay, I know that can be kind of goofy, kind of tricky. Let's see what that looks like over here. Okay, at this point, to reduce some confusion, I'm just going to leave this one as a regular absolute value one. So just coming off of the initial here, 0, 0, up 1 over 1, and so on. Okay, this is the only one I'm going to mess with. We are going to say, again, from a regular, y equals absolute value of x. If I do a minus 4, it moves it to the right 4, as we can see over here. If I do a plus 3, it's going to move it up 3. I'm going to turn this off just for now. So we can see I'm still here at my 4, 3. That's my vertex. I'm going up 1 over 1, up 1 over 1, because our slope on the outside here is 1. Okay, now all of a sudden, if I were to make my slope be a 2, again, my vertex is still here. I'm going up 2 over 1. It doesn't want to stay there, but up 2 over 1 would bring me to, 5, 5. Up 2 over 1 again would bring me to, let's get right on it. I didn't want to get right on. Oh, there we go, 6, 7, and so on. We continue to go up 2 over 1, up 2 over 1, and it mirrors on this other side up 2, left 1, up 2, left 1, because of this piece here. Now, if I were to put a 3 in front of this, okay, notice how the only things that changed was the left and right position of the vertex and the slope. Okay, the slope is no longer this 2, the slope is actually 6. From here, you would be going up 6 and over 1 to the next point. So instead of this 1 and 1/3, that's what 1.33333 is, we'd actually be at 2 and 1/3, and instead of here at 3, we should be up at 9. So let's see if we can find that exact spot. 2 and, really close. 2 and 1/3 is around 9 here, right? So we went up 6 and over 1. The reason I know it's up 6 is because I did 2 times the absolute value of 3. Okay? Now the reason that this is at 1 and 1/3, that's like saying 4/3. I took 4 divided by 3. So since it's 4 divided by 3, I know it has to be at this 1 and 1/3. Now let's say I'm at a negative here. Notice that this flipped over to the other side. Again, reason being, I'm taking my 4 divided by negative 3. Now 4 divided by negative 3 is negative 1 and 1/3, or negative 4/3. That's why it's over here. Okay? This slope, however, is still 6, because we have 2 times absolute value of negative 3. 2 times 3 is 6. So let's see, what if I used a 9 here. That might kind of make things a little bit easier to see. If we use 9, 9 divided by this negative 3, that's how we can see this exactly here. From here, we go up 6 and over 1. So it should be right here. Come on. Doesn't want to get right on there. Oh, there we go. Negative 2, 9. We went up 6 and over just 1. Right? Again, because 2 times absolute value of 3, but we did 9 divided by negative 3. Okay? So that is kind of the more complex or the trickier version if there is a b, if there's something in front of your x here. If there's not, you can just use this form and it keeps it nice and easy. Okay, last thing to go over then is for our inequalities. First you're going to graph your points, then you're going to use a dashed or solid line depending on your symbol. Then you use a test point. You usually use the origin, 0, 0, to see which side to shade. So this is, again, just like your linear inequalities. If I want to change this from equals to a greater than, okay, because it's greater than, not equal to, I have a dashed line here. I would check 0, 0. So is 0 greater than all of this? Well, apparently it's not because we've shaded in here. Negative 3 times 0 is 0. Minus 9 is negative 9. Absolute value is 9. Times 2 is 18. Plus 3 is 21. Is 0 greater than 21? No, it's not. So this spot isn't shaded. This area is shaded. Okay, so that's really all you have to do for your inequalities with two variables. You graph it just like you normally would. Use the test point to figure out where to shade. So again, this is your little more complex form using the b. This is your basic form, as long as there's no b in front of it.